Hello everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. So in the previous part, we talked about the diverse and unique features of the characters in Vampire Survivors, including their distinct starting weapons. However, that's not all. Each character also possesses passive healing and the ability to pick up items from range. However, we have yet to fully realize these systems in the game. Thus, in this part, we'll be focusing on bringing these features to life by implementing the character's starting weapons and the new functionalities such as the ones I just talked about. And by the end of this part, you should have something like this, which is recovery, which is passive healing, the magnet stat, which is picking up items from a range, and the ability to pick the characters and have their starting weapons spawn. And without further ado, let's begin. So we'll start by addressing the flow of stats. Now you'll be wondering what exactly this means. Well, essentially, in the previous parts, we did introduce something called current stats if you remember. However, we have yet to fully implement them, thus resulting in cluttered code as some of our scripts reference scriptable objects and others reference the current stats. So to remedy this, we basically just need to establish a streamlined process for all these stats to pass through a handler before being referenced. Now fortunately, we have already created stat handlers such as the player stats and enemy stats in the earlier sections. So let's start off with the player stats. Currently, the only stat we have directly referencing the scriptable object is the move speed. Now to ensure that our player's move speed is always up to date, we must create a reference within the player movement script to the player stats and access the current move speed instead of the scriptable object, so that this way the move speed will always reflect the latest changes. Now to accomplish this, we first need to lower the protection level of the relevant variables by going into the player stat script and making the variables public. Additionally, we can also give them all a hide in inspector attribute to hide them in the inspector. So once that's done, let's head into the player movement script and reference the current move speed like so. You can also remove the character data field as it is no longer needed. Now, as you may have noticed, the system that we are creating eliminates the need to assign these scriptable objects to any script that references them by routing all stat references through the player stats. This not only streamlines testing but also eliminates the risk of assigning the wrong scriptable object. Additionally, this design will also prove beneficial for future functionality we plan to implement. So we can now do the same for the enemy stats. First up, let's head into the script and modify the variables to make them public. Then, once that's done, let's head into the enemy movement script to reference the correct move speed. You can also remove the enemy data since we no longer need it. Back in the editor, hit play to test to see if everything is working as intended. Now for the weapon stats, there really isn't a surefire way of only having one reference to the scriptable object, as we need a reference for both the controller and behavior scripts of the weapon. Thus, we are only going to change the speed reference in the knife behavior script. Now within the script, we simply have to reference the current speed from the parent class. Once again, hit play and test to make sure everything is working correctly. Now that we have streamlined the stats, we can move on to adding new features to our characters. First up, we will implement the recovery stat that we omitted in the last part. Now the purpose of this stat is to allow the player to naturally heal when their health is below maximum, and once it reaches the maximum, the recovery will naturally stop. Now in the player stat script, we will create a new function called recover. This function will allow the player to gradually heal over time based on their current recovery stat, so as long as their health is not at the maximum, of course. We will increment the current health by a calculated healing rate, which takes into account the time elapsed since the last frame, which is time.delta time, to ensure consistency across different frame rates. It is important to remember to call the recover function within the update method as well, as we are using time in our calculation. Back in the editor, set the recovery rate of the character to be something like 1, so that the player will regain 1 health every second. And before testing, we need to make sure that the current health variable is public. This is because the hide in inspector attribute also hides the variables in the inspector, making it inaccessible even in debug mode. Now, if you hit play, you should be able to see that your character's current health automatically starts healing at a consistent rate. However, we are not yet finished. As with the restore health function, we must perform an additional check to ensure that the player's health does not exceed their maximum health. This is necessary due to the imposition of floating point values, and requires that we check and adjust the current health value to match the maximum health. Head back into your editor to test. Now, the character should not heal past their maximum health. You can also add back the hide in inspector attribute once you have tested. Okay, so now moving on to a different feature. So in the previous part, we implemented the ability to collect items such as experience gems and health potions. However, we did not account for the magnet stat, which essentially just governs the area which the items will be automatically collected by the player, which means that the player will be able to collect from range. So we essentially have to create the range at which the player can pick up the items. First up, open the character scriptable object script, and in here we just have to add a new stat called magnet. Afterwards, we need to implement the current stat of magnet within the player stat script. Now that the preparations are done, we can head into our player collector script and begin adding some adjustments. First, we will add a reference to the player stat script to access the current magnet stat. Next, we will create a new variable called playerCollector of type Circle Collider 2D, which will be used to detect items within the specific range. Now in the update function, we need to set the radius of the player collector to match the current magnet stat, ensuring that the range updates in real time. In the editor, make sure to set the magnet stat of the character scriptable object. I recommend setting it to something like 1.6. Before you hit play, there are a few important steps you need to take. Since we use the Circle Collider 2D component to create the radius of the collector, we now need to create a new empty game object under the player which we'll call collector. Then remove the player collector script from the player and set the Circle Collider 2D to be a trigger, so that it just doesn't affect the player's movement. Now, by creating a separate object for the collector and making sure that it is a trigger, we can just ensure that it won't interfere with the player's movement and will still be able to pick up items. You may have also realized, but because we are using a separate game object, we have to go back into the player collector script and make a simple change such that we have a reference to the player. So instead of using getComponent, we'll use findObjectOfType. Now when you play the game and collect an item, you can see that the player collects it from range. Awesome! Although this is fine, we can actually make an improvement to it to enhance the player's item collection experience. We can do so by adding a visual cue so that the player can tell when the item is collected. In Vampire Survivors, the game does this by pulling the item close towards the player until it reaches the player and then destroys it. We are going to do exactly the same. When an item is collected, it should be pulled towards the player and eventually disappear. There are many ways to move the item towards the player. For instance, we can use the transform.translate or simply move the position of the item towards the player. However, to achieve this, we will be using the add force method instead to simulate the force of the item being attracted to the player. In the player collector script, we'll create a new variable called pullSpeed to define the speed of the pull. And now within the onTriggerEnter2D function, we'll get the rigid body 2D of the item, create a vector2 variable called force direction that points from the item's position to the player collector's position and normalize it. And then afterwards, we just have to apply a force to the item's rigid body 2D in the force direction with the pull speed value. This makes the item move towards the player using force. Before we head back into the editor, make sure you remove the destroy game object line in the experience gem as it will interfere with the collection animation. Head back into your editor and make sure to add a rigid body 2D component to the blue gem or whatever pickup you are using for testing, or else the animation won't work. Make sure to also set your pull speed. I'll set mine to be 300 so that it's fast. Hit play and the pickup should fly into your player. Great. Now that we have an item moving towards the player, it's important to ensure that it disappears once it reaches the player. Luckily for us, there's no need for any fancy code to calculate the distance from the item to the player or whatsoever, as this can be easily achieved by using the onTriggerEnter2D method in the experience gem script. With this, we can simply destroy the object once it touches the player. Additionally, we can also include a debug.log statement to check if the collect function is being called before or after the animation. This way, we can make sure that the item is being collected and the animation is just a visual cue, meaning that the player has already collected the item from the range, and the item coming towards the player is just a cue to just tell the player that the item has been collected. So it doesn't mean that the item will only be collected after the animation reaches the player. Now head back into your editor and hit play. As you can see, the blue gem destroys itself after touching the player, and the debug.log line calls just as the pickup is moving, making our goal to make a visual cue a success. Awesome! So to make our code more efficient, we can create a parent class for all the pickup items. This way, we don't have to keep calling the onTriggerEnter2D method in every individual pickup script. To do this, we can create a new script called pickup and copy the onTriggerEnter method from the experience_gem script. Then we will just make some modifications to the experience gem and the health potion scripts. The experience gem script will inherit from the pickup class, and we can remove the debug.log line as it is no longer necessary. The health potion will also inherit from the pickup class, and we can remove the destroy game object line. In the editor, we can also test with the red potion to make sure everything is working as intended. Remember to add the rigid body 2D component to the red potion before testing. Now, we have a way for the player to collect pickups from a range and a stat to define it. Additionally, we have a clear visual cue so the player knows when they have collected a pickup. Great! Now that we have added additional functionality for the characters, let's wrap up this part by incorporating character selection and the spawning of their initial weapons. As a little heads up before we dive into this section, some of the terminology and concepts used might be daunting to some of you, so feel free to just take a break and research any terms or techniques that may seem confusing. Before we proceed to equip the characters with their respective starting weapons, it is crucial that we provide the player with the option to select from a variety of characters. In the game Vampire Survivors, players have the ability to make their character selections from the main menu alongside other customizations such as the stage, setting the maximum number of weapons and eggs, and so on and so forth. And once the player confirms their choices, they'll be taken to the game scene where the gameplay will commence. Our goal for this is to implement a method for transferring the chosen character's scriptable objects data from the menu scene to the game scene seamlessly. There are multiple options available for achieving this, such as utilizing Unity's player prefs or the SceneManager.loadScene async method, which allows for loading new scenes asynchronously. However, for reliability and flexibility, we will be using a combination of the singleton pattern and the don't destroy on load method. For those that are unfamiliar with any of these two, the singleton pattern is a design pattern that ensures that only one instance of a class exists within a game at any time. So this can be useful for storing data that needs to be shared between scenes, while don't destroy unload allows objects to persist across multiple scenes and is useful for preserving data that needs to be carried over between scenes. However, we must be careful with how we handle don't destroy unload, as it can lead to memory leaks if not used correctly. To get started, let's create a new script called character selector and a new scene called menu. Now, let's set up the menu scene. First up, we need to create a canvas, and under it, create two buttons called Select Knife and Select Garlic. Next, set their text to be Select Knife character and Select Garlic character respectively. Anchor both of the buttons to the center and space them out neatly such that they are a good distance apart from one another. I'll space both of them such that their positions are -180, 0, 0 and 180, 0, 0 respectively. Now you should have something like this. Open the character selector script and let's start adding some code. We'll first need to define a singleton. To do so, we have to just do the following. In the character selector class, add a public static variable called instance of the same type as the class. This variable will be used to store the instance of the class. Add a public variable called character data of type character scriptable object, and this variable will be used to store the selected character data. Lastly, in the awake function, add a check to see if the instance of the variable is null. And if it is, set the instance variable to be this and call don't destroy unload on the game object to ensure that it is not destroyed when the scene changes. If the instance variable is not null, destroy the game object instead. This ensures that there is only one instance of the class at all times. We can also add a debug.log warning to inform us of when there has been an extra character selector deleted, such that we know that we have made a mistake somewhere, or that there may be two of the same objects. We now need to add a public static method called getData that returns the character data variable. This method will be used to get the selected character data for other scripts. We mark it with public so that it can be accessed from other scripts, and static so that it can be called directly on the class rather than an instance of the class. So if this still seems confusing to you, just take a second to look at these two examples of calling the character selector.getData method. So in method 2, as you can see, if we omit the static mark, we have to call the method on an instance of the character selector class rather than being able to call directly from the class itself like with method 1. This would mean that you would have to have a reference to the instance of the class to be able to call the method. Now that that's out of the way, we can create a way for the player to select their character using the buttons that we previously created. Head back into the editor and let's create a new character scriptable object called garlic character for testing purposes. Next, in the menu scene, create a new game object called character selector and attach the character selector script to it. Connect the buttons to the select character method of the character selector script by creating an onClick event and assigning the appropriate character scriptable object to them. Now that we have a way to transfer data from one scene to another, we need a way to change the scene. Now obviously you could just change the scene by using the scenemanager.loadScene within the select character function. However, to enhance the organization and cleanliness of our code, we will create a new script called sceneController. This script will handle all scene transitions within the game. To begin, we will add the Unity Engine.Scene Management library, which is necessary for managing scenes in Unity. Next, we will create a function within the script that takes in a string representing the desired scene, and use the scenemanager.loadScene method to transition to that scene. This approach allows us to centralize scene management and keep it separate from other aspects of the game, and it is very simple to implement. In the Unity editor, create a new game object called sceneController and attach the sceneController script to it. Connect the change scene function to the buttons by using the onClick event once again and passing in the name of the desired scene. Make sure to also add both the scenes to the build settings or the load will not work. Hit the play button and click on any of the buttons. The scene should now change to the game scene, and in your hierarchy you should be able to see the scene controller object marked as Don't Destroy on load. Awesome. With the character selection process now complete, it's time to ensure that the chosen character's data is properly passed over to the game scene. This is a straightforward process as we've already streamlined that all stats have to pass through the player stat script while being referenced earlier in the part. All that needs to be done is to assign the character data variable in the player stat script to the result of the character selector.getData method. To verify that our system is working correctly, we can leave the character data variable as public and check its value in the game scene. Be sure to set the character data before setting the current stats as it will cause a null reference otherwise. Head back into the editor and remove the character scriptable object from the character data slot in player stats as we no longer need it. Now, if you play the game from the menu scene and click on any one of the buttons, the scene should now change to the game scene, and if you check the player in the inspector, it should have the selected character scriptable object in the character data slot. Great! Let's now ensure that our data transfer is clean and efficient by adding a method to destroy the singleton instance in the character selector script. As I mentioned earlier, we must be careful with how we handle Don't Destroy on load objects. This will prevent any memory leaks and unwanted game objects in the game scene. To do this, we need to create a new method called Destroy Singleton. This method will remove the instance and also destroy the game object. This way, we can be sure only the necessary data is present in the game scene and no unnecessary elements are running in the background. You could also set this method to be static, but you need to call instance.gameObject within destroy instead as an object reference is required. Now, all we have to do is call this method right after accessing the data in the player stats. We can also choose to remove the public keyword from the character data since we made sure it works. Now back in the editor, hit play from the menu scene. You should now see that when the scene transitions, the character data slot should be filled out with the correct scriptable object, and there should no longer be any scene controller game object marked as Don't Destroy on load in the scene. Awesome! Now that we have a way to transfer data of the selected character, it's time to spawn the starting weapon of the character, more specifically, the controller of the weapon. To wrap up the process of choosing a character and spawning the starting weapon, we need to take a few steps within the player stat script. First, create a public list called spawn weapons to track all the weapons currently held by the player. Next, create a public method called spawnWeapon that takes in a game object called weapon. This method will be used to spawn any weapon controllers and should be made public for access by other scripts. Within the spawnWeapon method, create a local variable called spawnWeapon and assign it to the instantiated weapon. Then, use the setParent method to make the weapon a child of the player in the hierarchy. Finally, add the spawn weapon to the spawn weapons list. Make sure to also call the spawn weapon method in the awake method and pass in the character data.starting weapon to spawn the character's initial weapon. To finally wrap up, go into the game scene in the editor and create two new folders under the weapons prefab folder. Name the folders controller and non-controller. And drag and drop the knife controller and garlic controller objects into the weapons folder and delete them from the scene. Sort the weapons folder by placing the prefabs in their respective folders. Next, assign the controller prefabs to their corresponding scriptable objects. Finally, return to the menu scene and press play. When transitioning to the game scene, you should see that the chosen weapon controller spawned as a child of the player, and it will be visible in the list of spawn weapons in the inspector. Awesome! That's all for this part. In this part, we went through how to create add-on features for characters, including selecting a character and spawning their unique weapon. I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a Patreon. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way, because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye!